Hello guys, and welcome to another Hackerrank video. Today we're going to be solving divisible sum pair. In this problem, we're asked to pair up numbers that equal to k. And when I first saw this problem, I thought, okay, well, it's easy to have an n-squared solution, but it closely resembles two-sum problem that we've seen on LeetCode or some other website. So I decided to take that approach instead to try to solve this problem. And then I quickly ran into cases where we had multiple zeros that needed to be handled for factors of k. So I thought, okay, hey, the two-sum problem uses a hash map. Why not start with a hash map and then figure out the best way to actually handle the zeros, which I eventually did after looking at the problem for about 30 minutes and whiteboarding it. So I'm going to go ahead and show you guys my approach. So what I'm going to do here is pick the initial numbers plus some extra numbers, and we're going to use 5 as k. So what we're going to do is start. Let's go ahead and put our numbers down. 1, 2, 3, 4, 5, 6, and I'm going to add in 10 and 20. All right. So the first thing we want to do is keep a pairs variable to hold our pairs. So I'm just going to call this one pair, and it's going to equal to 0 for now initially. And what we want to do is keep a hash table or hash map. All right. Wow, I'm such a good drawer. Sorry guys, I'm using my mouse, so it's not the best. So what I want to do is keep a mod variable, and you're going to keep a complement variable. And you're going to start with our first number here. The first number is 1, and our k is going to equal to 5. So we're going to say 1 mod 5 is going to equal to 1. Now we'll say 5 minus 1 to get our complement is going to equal to 4. So what we do first is we check our complement within our map. It's not in there, so we can't really do anything, but we need to go ahead and store our mod. So our mod is going to be 1. And we've seen it the first time, so it's going to have the value 1. And then we can go ahead and go through the next number in the array. So we're going to be at 2. So it's going to be 2 mod k, which is 5, which is going to give us 2. And 5 minus 2 is going to give us 3. We check is 3 in our map. No, it's not. So we store 2 and 1 because we've seen 2 for the first time. And we can go ahead and go through the next number. So we are at 3 now. And it's going to be 3 mod 5 is going to equal to 3. 5 minus 3 is going to be equal to 2. So we check our map. Do we have 2 in our map? Yes, we actually have 2 in our map. So what we're going to do is we're going to go ahead and add. We found a pair, so we're going to go ahead and add 1 to our pairs. And we seen 3 for the first time, so we're going to go ahead and add 3 and 1. Sorry for this. Okay. And then we go to our next number, which is going to be 4. So we're going to say it's 4 mod k, which is 5. It's going to be equal to 4, and 5 minus 4 is going to be equal to 1. All right, so in case of complement here, we do have 1. So we're going to go ahead and add another 1 here. I'm going to say plus 1. Okay. And since we've seen 4 for the first time, we're going to add 4 into our map and 1. And then what we're going to do is go to our next one. And in this case, we actually have a number, 5 mod itself, which is a factor of k. So this is going to go ahead and give us 0, right? So we can just say that, we can just say 5 minus 0 to give us 5, because the whole thing here is to look for numbers that are less than 5. So when you mod a number, right, you get numbers that are less than that number. So it's going to be between 0 and the number minus 1. So in this case, if we are at 5, we don't actually want to use 5, we actually want to use 0. Okay, so wherever we see this thing here, a factor of k, we use 0 instead. So for this point, we don't really have 0 in our map, so we put a 0 and a 1. And we move to the next one. Sorry about the bike noise. I live near the road, so it gets noisy. And the next thing we want to do is go to 6. So say 6 mod 5 is going to equal to 1. 5 minus 1 is going to equal 4. So we're looking in our map, we have 4. So what we do is we add 1 up top. Okay, and then what we have is we have 1 already. So what we're going to do is increment the value in 1. Right, since 1 is already in the map, we're going to go ahead and say now we've seen it twice. And then we're going to go to our next value. And we're going to be at 10 now. So we're going to say 10 mod 5 is going to equal to 0. So remember what I said, when we see this thing, when we see a 0, pretty much you can't just say 5 minus 0 is going to be 5, because it means something that's less. So we know that for this one, it actually needs to be 0. So what we do is we check our complement here, and we have for complement, we have a 0 here and the value is 1. So we're going to go ahead and say 1 here, and then we're going to go ahead and increment this value here. Okay, now we're at 20. Let me erase this. So we're at 20, and still the same thing. 20 mod 5 is going to be 0, and I'm going to say 5 minus 0. It's going to be 0. And what we want to do here now is check our complements thing. So 0, we have a 2. So we'll say plus 2, and then we increment. We add increment this to 3. All right, so this becomes 3. Let me just go ahead and clear this out. Oops, and it's fine. Just put 3 here. Okay. All right, so now we've gone through the last numbers, so we can go ahead and add this up. So it's going to be 1, 2, 3, 4 plus 2. We get 6 here. So let's actually go ahead and build this list manually. So what we do is let's start it at so 1. Right, we're going to go 2, 2 and 3. So 3 and 2, because it has to be less than that. And then we have 4 and 1. Then we have 6 and 4. Then we have 5 and 10, right? And then we can also have 5 and 20, and then we have 10 and 20, which gives us a total amount of 6. So we have 1, 2, 3, 4, 5, 6. All right, so we've seen how to solve this. Let's go ahead and actually code this up using this logic. All right. Yeah, there we go. So what we need to do is first keep our pairs. It's going to be equal to 0. And then we need a hash map. So we're going to do a map. I'm going to use, let's do integer and integer. And call this map. It's going to equal to u hash map. All right, and then we can go over the loop. I'm going to say for int value, and then we're going to pass r here. Okay, so the first thing we're going to do is keep our mod. So we're going to say mod is going to equal to value mod k, and then to get our complement is going to equal to k, right, minus the mod. However, since we know that sometimes the mod will give us, so for example, if we say you know, 10 mod 5 equals 0, k minus, if k was 5, k minus 0 equals to 5. So we actually take care of that case. So in this case, we're going to say if k minus mod is equal to k, meaning that it's the same number, then we actually want to replace that with a 0. Else, we're going to go ahead and actually do the k minus mod. Alright, so now we check for our, we're going to check for our complement. So we're going to say that if map that contains key complement, then what we want to do is we want to add the value to our pairs. So we're going to say pairs plus equal map dot get complement. All right. So now what we can do is we can say that if map that contains key and it contains the mod, then we're going to go ahead and actually increment that. So we're going to say map dot put, and we're going to put the mod, and then we're going to do map dot get mod plus 1. All right, and we could just copy this. Let's just copy this. All right. So now we're going to say if map does not contain mods, meaning that we're seeing it for the first time, what we're going to do is just put the mod in the map and 1. So we're seeing it for the first time. All right, and then once we're done with this, we just need to go ahead and return pairs. And this is pretty much it for the problem. Okay, now this is pretty much it for this problem. So let's go ahead and run this. And we're good. And let's submit. Alright guys, this will be it for this problem. I'll see you guys in the next one. Have a good day. Bye bye.